anyways, we're going to start the night off with some CTF goodness. And then we're going to follow that up with some news reported by our execs. I believe it's Jem, Yusuf, Jamie, and Luai. And then once the news has you all, I guess, warmed up, we're going to hit you with some absolute bangers, which I'm sure, I think Yusuf, is that the terminology they use? Confirm?
I don't hang around too many young people because I'm always around you guys, so I wouldn't know.
Okay, well,
Banger
regardless,
seems right though.
the
Banger
yeah, we
seems
got
right.
Repo rundown by Nick, and we got our featured guest speaker Neil Desai bringing you the hottest information about network defense basics. So yeah, but before we do all that, I just have to let me talk about some CTF news. So if you don't know, or you've been in the dark for a bit, a couple days ago we opened registration for our CTF, which is starting on March 27th and 28th. You can see this giant flashing register now sign. If you haven't registered yet, go to ctf.issessions.ca and sign up. If you don't have a team yet, it doesn't matter. You can join one in the next few weeks. The most important thing is that you sign up now to secure your spot in the CTF. And I just have to say, like, the amount of signups we've gotten in just 2 days is amazing. So it's great to see the response from the community and like their enthusiasm for registering. So I'm really excited about that. And then there is one other thing. If you didn't know, we have prizes. We already announced 3 grand prizes worth hundreds of dollars to the top 3 teams. However, I can now also confirm that we have secured like another $2,400 from the SSU to allocate to more prizes. So that significantly increases the prize pool, allowing us to include way more teams than before. And we'll have more details on that and what those prizes will be. So just stay tuned. Stay tuned for that. Yeah, and that's pretty much everything on the CTF. I'm excited, and I hope you guys are too. So once again, if you haven't registered, ctf.issessions.ca. Tell your friends to register as well. Try to build teams, and then we'll also help facilitate teams if that's required. But yeah, awesome. Let's move on to the news, starting with Luai. How you doing?
I'm doing pretty well. That was a great announcement, wasn't it?
Was it?
Woo! Fire! Yay! Excited!
Woo! Yeah. So if you are not motivated by learning and workshops, but are motivated by money, there you go. Plenty of money. With that being said, let's get to the news. So our first news story is a new group called Hafnium is targeting Exchange servers with ODE exploits. So who is Hafnium? Hafnium is a state-sponsored group. It's based out of China. It's only been identified sort of in the last year or so by Microsoft. And in the last campaign, it has been targeting essentially on-prem Exchange mail servers that are publicly exposed to the internet. So Hafnium typically targets internet-facing applications, and they're typically exposed by in industries like defense contractors, pharmaceuticals, higher education, law firms. Of course, what's the only thing in common between all of those parties? Well, they have a lot of usually intellectual property, or they're holding some very important secrets, and that's probably what factored into the attribution that that Microsoft did, which is to attribute the group to China and to conclude that it is actually state sponsored. Of course, attribution is very hard work, and a lot of stuff goes into that, but that's probably one factor. So what are they doing right now? They're actually using a combination of 4 ODE exploits. These have only been observed in the last couple of days or so. You've got a server-side request forgery vulnerability in on-prem Exchange servers, an insecure deserialization, and then 2 arbitrary file writes. And once you change all of those together, you essentially have system access to an Exchange server. Of course, again, this is on-prem servers, not the managed server that you can get through Microsoft. So once Hafnium has actually gained access, right? So once they've actually, changed those 4 ODA exploits, what they do is that they deploy a number of web shells, specifically ASP, and then looking for more credentials, they start dumping LSAS using procdump, which is actually a Microsoft tool. It's a sysinternals tool. Then they go and start looking for data to steal. And they're pretty much looking for mail data and user data in this particular attack targeting Exchange servers. And what you'll notice actually in sort of this attack chain is that they are very, very heavy users of LOLBAs, or living off the land binaries, meaning they try as much as possible not to bring in new tools, but to use tools that already exist on the operating system to try and maintain stealth, which is really cool. So what's the solution to this attack? Well, Microsoft Advisory has been released, so you need to patch those on-prem Exchange servers. Another thing that you probably should be thinking about is, does your Exchange server really need to be publicly exposed to the internet? Can you, for example, put it behind a VPN, or could you limit who can connect to that server to maybe a select few people or select IP range? And then so that's how you sort of either completely destroy the threat or mitigate it. How do you detect it though? The way that you detect it is actually by looking at that Microsoft Advisory. And I have to say, like, that Microsoft Advisory and a lot of the Microsoft advisories that have been coming out have actually become like really, really awesome. Microsoft has been releasing like tons of IOCs, scripts that allow you to determine whether you are vulnerable, and a lot of hunting queries as well that allow you to see, okay, am I a target of compromise, and what has that person done on my network? And if you actually compare these advisories to what Microsoft was doing back in, say, 2008, 2009, you'll see that there's actually quite a bit of difference, right? Microsoft now shares all the information, whereas before they used to only share sort of very, very specific nuggets of information. So, kudos to Microsoft for being more open now. So that's the first story, and then my second story is so there's actually now a new runtime defense against Excel 4.0 macro malware. This is called XLM macros. So the defense is by integrating runtime scanning of XLM through AMSI. So I know that's a lot of acronyms, so let's break that down. So what is Microsoft's anti-malware scan interface? So the AMSI interface is this open interface that essentially allows any application, for example, Excel, to scan certain data, to request a scan of certain data from the installed antivirus solution, right? So for example, if I have a macro that is running in Excel and that macro is executing, it is going to be making certain function calls, and those function calls typically translate to Win32 API calls. What Excel can do is it can request that Windows Defender or McAfee or Bitdefender, whatever it is, listen into the API calls that are made by that macro. And then if they see like a suspicious kind of sequence of events happening, then then AMSI or that antivirus solution can go and respond, and it can kill that process, or it can issue a warning to the user or whatever it may be. So that's what AMSI is and how that works. So what's XLM? XLM is basically just an older version of an Excel macro. So macros, the modern version, are typically contained in these things called OLE streams, right? Which are kind of like objects inside of an Excel document. But an XLM macro is actually something that exists in the cells. So it's kind of, it's more obvious if you just like open an Excel document, but it can also be anywhere. It's kind of a bit more difficult to analyze forensically. It's not that much more difficult. Of course, anything can be automated. But it is slightly more work to be able to sort of reconstruct the payload, for example, when it is an XLM macro. So XLM macros, of course, can be used to launch arbitrary code using like a phishing attempt or something like that, using a booby-trapped Excel document. And the good news is that now AMSI can actively scan this type of macro which is not something that could have, it could do before. So again, two Microsoft stories, both good news for Microsoft. And those are up to my two stories. And up next, we have Jamie with a couple more stories.
First things first, I just want to thank whoever decided to put me right after Lue. This will be shorter. So
the
for
only
all
person
of
that
you,
can fill those shoes.
I'm so happy you said that, Jamie. Thank you so much. I love you.
Don't worry, guys. An important aspect of the security lifecycle is accountability. So I'm just trying to make sure us on the exec team all stay accountable. Lue. Anyways, so everybody here was at my Arch Linux workshop. I know you were because y'all are faithful to this club. You should all know what Grub is. Grub is probably the most popular bootloader used in most Linux distributions. Now, it goes all the way back to 1995. I wasn't even born yet, so that goes to show you that this is a very old, tried and true bootloader. Still experiencing vulnerabilities, which is a good example of the update bug cycle that we go through in software. So, what happened? You would think after 20 plus years they would have figured this out. Well, no, they didn't. So, using this boot hole vulnerability allowed the threat actors to completely bypass UEFI secure boot. Secure boot, I don't know why all of a sudden I have an accent. Secure boot is a protocol which basically forces system level drivers to have to be signed. And this is beneficial because it really makes it more difficult to hijack system level services. Really important, especially on Windows. So how do they completely bypass this thing? Well, they used a vulnerability known as boot hole. And boot hole was then extended with a rootkit, cleverly named bootkit, which allowed privileged access on every single boot. They accomplished this by basically exploiting a vulnerability in the parser. That's the word I'm looking for. The parser for the configuration file, which we actually worked on in the Arch Linux workshop. And I also famously messed up, which caused it to break. So that configuration file is incredibly important. And the parser that actually takes that and then converts it into machine code that the machine uses is vulnerable to buffer overflow. So at the base of all this is a buffer overflow. So by taking advantage of this parser, they were basically able to inject bootkit, and it emulated the Grub2 service. So when the system booted up, Secure Boot didn't even think twice about this being a potentially hazardous piece of software because it thought it was the Grub bootloader. So 117 patches were rolled out to fix this. However, this is a powerful lesson to show us that even though a technology may be mature and ever growing, there are still vulnerabilities that we need to pay attention to and we need to work on as these things are always happening. And that kind of goes on to the next story. If Kurt would so kindly push that forward.
I may have mixed you up.
You gave Lue two in a row?
Keeping you on your toes. Keeping you on your toes.
All right.
Got a freestyle now. Cool. Great stories. Super technical stories. I'll be honest, my stories are not going to be that technical, but still pretty interesting. Oxford University's COVID-19 research labs get hacked by some Russian hackers. This lab is like top tier lab. It's got some of the world's most renowned professors, and obviously, naturally, this would lead to some of the most innovative research results. Oxford University confirmed that it detected an isolated incident in one of the divisions inside this lab. The division that got attacked was where the machines that are used to prep biochemical samples are housed. So it's definitely a critical branch. University wasn't able to comment on the severity of the breach, but they said that they already talked to the National Cybersecurity Center, which is a branch of the GCHQ, the British Intelligence Agency. They said that they've already began an investigation, so things are underway. They claimed that there was no impact on the ongoing research, and they actually said that none of the affected systems actually contained confidential patient data. So that's a definite relief. This breach was initially brought to light by the security researcher Alex Holden, who showed screenshots of the hackers with their actual level of access, and it showed that they have access to the interfaces of the lab equipment. They have the ability to control pumps and pressures and a bunch of other stuff. Cybersecurity expert at the University of Surrey, Alan Woodward, said that since the attackers were actually selling this access, that's how the screenshots came to light. They were actually in the darknet black market selling this access. He doubts that it was a nation state actor, but instead this group is actually thought to be a group that sells this intellectual property to nation state actors, on their own. They're not actually nation state, but they do interact with nation state actors. Alex Holden, that security researcher, also went on to say that, that was the Alex Holden was the security researcher from who found the initial screenshots. He said that this group is highly sophisticated, and they've actually been selling private data for various APTs. He said that their list of victims include a bunch of Brazilian universities, as well as a massive, like a consultancy firm kind of thing. Their name is Dun and Bradstreet. I actually never heard of them before, but I looked them up, and they're like a multi-gazillion-dollar company. So definitely I don't know if you want to call it decorated, but hefty list of victims in the past. So these guys are no joke.
I think people don't think about infrastructure very often. Like security terms, I think people just take it for granted. But like if your infrastructure goes down, like Texas did, which wasn't an InfoSec necessarily a related incident, but
oh, dude, I just realized I read my second story. Oh man, that's a bummer. I just looked at this, and this is the Russian GRU. I have 2 stories, and oh man, that's a bummer.
Hey, you know what?
That one. Yeah, exactly. I'll get this one out of the way. I was going to say, because that one was really interesting, but this is my favorite one. This one's like really, really intense. And yeah, that's why when I started talking about infrastructure, I was like, wait a minute. I'm talking about COVID-19 research. I looked at the picture and it kind of told me it's my turn, but then I had my ordering difference. So that one's a cool story too. But this is the real story. This is really nice. So, okay, let's start from the beginning. So this story is wild because it kind of implies that, Russian hackers have been not just targeting, but actually when I go on with the story, they've actually been in the U.S. grid intermittently for years, since 2017. So Dragos vice president of threat intelligence and actually a former NSA analyst, Sergio Caltagirone, says that this newly named hacker group, who you're going to hear the name of in a second, I guess Camosite, I have it written right here. They've been targeting U.S. electric, oil, and gas and other industrial entities since 2017. He goes on to say that in a handful of these cases over the last 4 years, the group has actually breached those entities that I just talked about, and they've maintained, quote unquote, quite persistent access, which to me is pretty scary. I mean, yeah, that's wild stuff. So Camosite is believed to have served as the access team to GRU's infamous Sandworm hacker group. I don't know if you guys have heard of Sandworm, but they're huge. They're known as the group that famously shut down the power supply to Ukraine, both in 2015 and 2016, I think. Also, Andy Greenberg wrote a wild book about them. Definitely go check it out. He's actually one that wrote this article as well. So really cool stuff. Yeah. So Camosite is believed to have served as Sandworm's access team. Luckily, Caltagirone says that Dragos has only confirmed successful breaches of U.S. networks, but none of those breaches have actually led to disruptive payloads. That's what they're saying. The main intrusion tools that they've used so far is spear phishing emails with malware payloads and brute forcing cloud logins of Microsoft services like Office 365 and AD. Now, once they gain access, they maintain access by exploiting valid user accounts, and sometimes they've even been seen using the credential stealing tool, Mimikatz, to dig deeper into the victims' networks. This next part's really interesting. So Camosite is believed to be an access group, and there's another group called Electrum who is believed to be they're what you would call an effects team, I think, right? Let me just confirm. Yeah, they're an effects team, and the effects team is responsible for destructive payloads after access. So what some researchers at Dragos are saying, what they believe is that Camosite and Electrum together make up the infamous Sandworm. The separation of these two groups is done by Dragos to seek to break down Sandworm's activities differently than other researchers who report on these activities. It actually allows them to kind of create a more, there's a more detailed web of different attacks, and it lets them get more detailed. Basically, the article goes in really deep on it, but they are separated. They separate Sandworm into this newly named group and Electrum, who's actually been known for a long time. Wired actually reached out to other firms like FireEye and CrowdStrike, and neither of them could confirm seeing Sandworm-related intrusions targeting U.S. utilities. But FireEye said that they've reported seeing similar intrusion campaigns by another Russian hacker group, who I think a lot of people know, APT28, which is also known as Fancy Bear. Dragos's report, the most recent report that all of this came to light from, it actually names a bunch of other groups that have been targeting U.S. industrial control systems. Not that they've gained access, but targeting. One group is called Vanadinite. This group is connected to the Chinese hacker group known as Winty. And another group named Talonite. And another one named Stibnite. I don't know why all these guys have night in their name, but they're not
Sounds
really
like a Marvel.
Yeah, they're definitely separate groups. So I don't know why they're all named Knight, but they are. And although this next one, this is the one that I talked about during the last sessions meeting, and another hacker group which actually attacked the water treatment facility at Oldsmar, Florida, which, like I said, I talked about the last sessions meeting. So go check that out. But Dragos's report basically names that there are a handful of groups that are attacking U.S. infrastructure, but Camosite is the one that's actually known to have gained access and persistent access. So even though, the last point here is, even though these guys haven't, they haven't resulted in complete chaos yet, Dragos's report says that this is really, really disturbing trend. And this is, the last 4 or 5 years has kind of been like a steep incline in the number of targeting situations with U.S. infrastructure. So wild stuff.
Beautiful. Thank you, Jim.
Yeah, thank you. Sorry I screwed that up.
No worries.
Yeah. Nice.
I am lucky to be members of this because they talk so much, which leaves me to talk very little, which I like. So that's good. Thanks, guys.
You're welcome.
So this was kind of interesting because after everything that's happened in SolarWinds, this article kind of reviews that and kind of goes into details about how organizations reacted and how they're currently reacting or not reacting. And I did this for an assignment in my auditing class, so I was like, hey, why not talk about this today? So basically, the article goes into details of 2 incidents where the negligence of the breach led to a breach. So it talks about 2 stories where an ATP believed to be backed by Russia was able to deliver a piece of malware to over 18,000 customers at a Texas-based IT firm. So this IT firm had left the SolarWinds exposed on the internet, and obviously didn't patch it after after SolarWinds released all the patches. And then it goes into a second where a different ATP out of China delivered a malware named Supernova. So it's really interesting to kind of see how certain organizations react, or in this case, didn't even react. And it also gives some alarming numbers. So only 25% of organizations exposing SolarWinds to the internet removed the instance right when the breach happened. And then in addition to this, only 8% of organizations who still expose SolarWinds to the internet patched the platform. These organizations include state and local government agencies, universities, hosting providers, and Fortune 500 firms. So like my take on this is just, it's like alarming for numerous reasons. One is like, do they even know that they have this bad piece of software on their platforms? And if that's the case, that's just like scary. That's terrifying. Because that's just dangerous and they're not aware of what's happening. So it's interesting for me in that regard. But yeah, that's that story. I'm assuming I'm going to go straight into my next story.
Probably
if
not.
That is
Let's see.
correct. No? Okay, cool.
Gotcha.
This is
Keeping me on my toes.
Jamie, tell us what you were talking
can
about.
You talk?
About? All right. I'll tell you about Scarboot.
Take longer than me.
All right. No, I'm actually excited about this one. So this goes back to a premise that I've talked about way too much, which is that people are the most important link in the chain of security. And this goes to show this because this is a very avoidable hack and it's very simple to execute. You could do this with a free Wix.com website. So what these very clever fellows did was they went on Google, they typed in how to hide a zip file in a BMP image. And a bunch of results came up with tutorials on how to do it and tools on how to do it. So they downloaded a tool, they threw their code in a zip file, threw that zip file in an image, hosted a website, and then got a bunch of people to go to it. And they pulled off a pretty substantial hack doing this. So why am I kind of oversimplifying this? I'm oversimplifying this because I think a lot of times we overcomplicate the level in which these are scams, right? These are digital scams. Any kind of phishing, social engineering hack is just based off of the old school framework of a scam. And this is exactly what this is. So what they did was using steganography. I'm happy I can finally pronounce that. It's taken 2 years to pronounce that word properly. It's not very well known because we don't think about it. We don't think about images as anything other than that, an image. What you have to remember is that the image is stored in a container, such as BMP or JPEG or PNG. Those are they're also compression protocols, but they're containers, right? So within a container, like we can put stuff in there. We don't have to put image information. We can just put information. So like I said, they host these malicious websites and using phishing and getting people to click on links that you shouldn't be clicking on. Stop clicking on suspicious links. And if you have the condition that which you have to click on a suspicious link when you see it, I'm sorry, but you're not the millionth winner. This is what happens. You go to the website and using what's called a server-side macro, which is a code that generally is used to run every single time someone goes on a website, the macro deploys the payload as the zip file. So it's decompressing the image server side, sending you the zip file without you knowing through cookies, and then deploying this remote access Trojan, which gives them access to your computer remotely. Like I said, people are the most important link in this chain. This entire hack could have been completely avoided if people wouldn't use these links and would have a little bit more education on how these things happen. Very easy hack to pull off, very effective. Simple technologies being used in a very clever way have caused havoc. And I thought this was a very unsavory example of the expression, a picture equals 1,000 lines of code. And it's not even 1,000 lines of code. The whole macro is about 30 lines, and it's caused this huge issue. So I thought it was a nice example to show everybody that not all of these hacks have to be super sophisticated using bleeding edge technology, but with a little bit of elbow grease and ingenuity, you can pull off some pretty impressive stuff. And that's all I have to say about simple hacks.
You know, if anybody's interested in steganography, we do have some challenges on it. So if you check that out, you'll be prepared.
Man. I was going to say the same thing.
And this is Jem's long lost news story.
I'm sorry, you guys already heard it. It was awesome. But here's the cool visual and dot jots, which you can access on the YouTube recording after this meeting.
Beautiful. Yusuf, take it away.
Cool. Thanks, bro. So this one's kind of interesting because it shows that like being a bug hunter or a bug bounty hunter kind of pays off. Sometimes I say that like with like a big sometimes because oftentimes it doesn't. But it's kind of cool because this one is a bug where a researcher found that he was able, or he or she or they were able to exploit this takeover vulnerability and get access to any user's accounts without their consent or permission for that matter. The researcher's name is Laxman Muthia. I probably butchered that. I apologize. They also said that this vulnerability only exists, or is supposed to only exist on consumer accounts. Obviously, it's been fixed now. But essentially, what it is, for example, if I was to try and take over Luai's Microsoft account, so luai@microsoft.com, I would go and I would say I forgot my password. It would ask me to input my email. I'd put in luai@microsoft.com, and then it would say that it sent me a validation code or a verification code, and through that I would try and brute force it to actually change Luai's password. But obviously, you're probably thinking now, well, that's not possible because there's got to be some sort of rate limitation to prevent people from brute forcing it, right? Because it's just a 7-digit security code that is completely doable to brute force. But when you have something like rate limitation, it prevents that. So the researcher basically, through looking at the HTTP post request, was able to really try and figure out and understand how Microsoft was encrypting these codes, and kind of a lot of background information on these codes. And through that, they were able to figure out that if they sent these brute force, I guess, requests, you could say, simultaneously, that they would be able to actually get some responses if the code was correct. And so yeah, that's basically what the bug is. Obviously, super simplified, but they earned $50,000 for it. And they also discovered a similar. So this was after they discovered a similar vulnerability on Instagram. So kind of interesting, kind of cool. But yeah, I basically now broke into Luai's Microsoft account if he has one. And
Beautiful.
that's my story.
Thanks, guys. Great news. I was secretly rating you all on your news presentations, and
I just realized Luai wasn't even here.
he
What a
had well, that's
loser.
why he went first. He's a busy man. He'll be back. Don't worry. And
Should
anyway,
he,
I
like,
rated you
you-
all 10 out of 10, so did great. Yeah. If you want more details on any of the news stories that were discussed, I will have them link. Actually, I'll link them right now. I'll link them in the news channel, and then I will put them.
Sorry, yeah. I am good, thank you. How's it going? I'm just finding the share my screen button. Cool. Can you see that? Awesome. Cool. So hey everybody. Little something different this week. I decided not to do a security tool for the second rundown in a row just because I wanted to look at different stuff for once. Some of you might be aware of the holiday, like Christmas holiday programming contest, the Advent of Code that they run every year. And sometimes I like to see, how other people have approached and solved some of these challenges. And this one entrant had like a visualization that went along with their solution to the challenge, which I thought was just really awesome. And I wanted to go through the visual piece of that. The author of that solution was Salt Die on GitHub. There's the link to their code for day 8 and actually all of their other solutions for 2020. If you're the Advent of Code is still up. You can go and try to solve those challenges if you want. So like, why on earth would I want to talk about one of these things? Well, first off, I really like the Advent of Code, and I think other people should try it out. Programming challenges are a lot of fun. They're different than CTFs. It tests a whole different area of your like comp sci skill. I also happen to really love nice looking visual design for terminal applications. That's why I always point out when apps have cool like ASCII art logos. And traditionally, you could like do programming in terminals using a library called curses or ncurses, which is how in a terminal you get like the stuff on the that you're seeing on the right, like bar graphs and boxes and other like content like that. Like if you're ever wondering how did they program something like Vim or Nano or any other like interactive terminal application like that, it would be through likely the curses interface. This is a different application. This one's called GTOP. It's on GitHub. It's awesome. Just gives you like performance stats in your terminal window in Linux. It's amazing. But this one's built on Node.js, I think. Anyways, moving along. So the actual problem for this one, it's interesting because the problem had to do with you're like some person on an airplane and you have this handheld game console and there's like this infinite boot loop, so you're actually looking at and patching the like boot ROM code for like this for this fictitious handheld game console. So you see on the right side of the screen an example of what the input to the problem would be. It would just be a bunch of these lines, and basically there's like 3 simple assembly instructions included in this bootloader that you kind of had to process. So the NOP just meant do nothing, go to the next line. The ACC and then some operation meant like you have a single register or variable to work with. So that would mean add 1 to the accumulator register or accumulator variable. And jump just meant like, jump plus 4 lines or jump back 3 lines. And that was your input to the problem. And you had to do some computation on that to find out where there was an infinite loop. But we're not going to talk about the problem solution. I'm not so much interested in that. You can go figure that out. What I want to talk about is how this person designed their visual solution, which is just beautiful. So I made a really terrible GIF of me running their solution. this is it. This is like written in Python, interacting with ncurses. All those dots in the middle represent like the instructions at a particular location in memory. You see the instructions they're processing going by on the left. That was me terminating it. I'll run it again. Across the top, they have like a status message. On the right, they have the memory address they're processing. On the far right, they have the value that's in the accumulator. Like, it's just really, really cool. This was just a visual presentation of their solution to that programming problem. Again, it's super cool. So obviously I saw that and I freaking loved it. And I was like, I need to talk about this. So into the code we go. Pretty minimal on the imports side, really just importing the standard Python library for interacting with the cursor's environment. So basically positioning the cursor within your shell in Linux or Windows. The regular expression library and the time library that really we're just importing to get a delay, because you have to introduce delays when you're doing animation in computing, because otherwise it would go too fast and nobody would see anything. So the window on the bottom here, they're just doing some creating like some constants to represent the various code instructions. They set up a couple of lists that are going to hold like various colors that they're going to use. They open and read the data input file, but again, that's not super important for what we want to look at. So they wrap the main function in a call to sort of this initialization for the curses library. And then they actually call their own self-authored method called initScreen or initSCR, which does the stuff that you can see in the second window there. So like it clears the screen, it starts to intercept some keystrokes from the keyboard. It turns off some like certain types of output, which is what the curses.noEcho means. Then it defines a bunch of basically predefined color palettes and constants, so that they can, assign different colors to the instruction, like the code instructions as you saw them running, different colors for those like round circles that represented memory. So they're just predefining colors. Then main calls setup windows. Setup windows is where it literally sets up the 4 or 5 different windows that you saw, like those. If I skip back, when they run it, the actual square boxes around the different data areas, they're saying set up those windows. So really what they're doing here, you can see in the comments in the code or my messages on the right, the message window, which was that status bar across the very top. They just use the cursors library to draw a rectangle, give it a starting XY, a size, and then set some color. And then they basically take that window that they've created and they call it messages. So they basically have dumped this window into a variable. And they do that for the address and accumulator window, the op history window, which was the one on the left that had all the instructions scrolling on it. They do it for the data window, which is where all those circles were representing memory. That like little mini for loop inside this data window is actually what draws the circles inside that window. The circle itself was just like an ASCII character that was like a filled in circle. And so since it was a regular character, you could color it with the same way you would color fonts, which was a really cool approach. The last couple lines in this function, they refresh the screen, which basically just means redraw the screen, which is a common operation when you're doing like animation. And then they return all of these individual windows as objects from this function, which I love Python because you can return multiple things from a single function. It's beautiful. So that was like their setup. So how do they actually draw to the window? As you saw, there was like 5 or 6 windows. I'm only going to cover how they wrote content into the operation window, which was the one with the instructions on the left. The process is the same for all the windows though. So I've tried to draw you kind of like their flow here. Down in main, they're basically doing the calculation that solves the problem. This is the window on the left here, or the box of code on the left. Eventually, they're doing their calculation to solve the problem, which we don't care what it is, and they get down to this lines that says visualize visualize computation, and they pass in value indicating the amount of delay that there will be. For animation purposes. So then the visualize computation function, it basically runs the delay on each of the windows. It's like 0.9 seconds or something like that, or some fraction of a second. And then it updates all of the individual windows. So you see I've got an arrow pointing from update ops, which is update that instruction window. So the update op function, according to my comments on the right, you basically scroll the window text, so you move it up a little bit. You get the XY position of that window. You print basically the next line of code you read from the input file onto a new line that you created by moving the text up. Then it's funny, you write the text and then you put the color over top of it. It's not like you write the text in green or whatever. You write it, then you apply the color change to it. And the individual windows don't redraw themselves. The last instruction there that says it's basically like no auto refresh, like don't refresh the whole screen yet, because if you look at the top right window there, the red box that's outlining that one instruction that says curses.do update, that will update all of the windows at once. So you get this nice seamless, looks like every window is being redrawn at the same time operation. And that's basically it. That's the loop that this goes through. So like do the calculation for each window, update the contents of that window, and then redraw the entire program, which I kind of have just explained here. So again, the flow of this whole solution: define all the colors, initialize the windows, like the curses system, draw the components that you want to have on the screen that are going to be permanent, like those rectangles. Then they actually do the code to solve the problem. Every time they go through a step of solving that problem, they write the contents of their solutions to those 5 windows. You redraw the screen, you wait a fraction of a second, and then you go back to step 4 where you keep doing your calculation. And that's the overall structure to this. Why is this neat? Why is it fun? Like, why do you care? Because now you can go and you can take these libraries and you can draw all kinds of cool terminal applications. So as an example, in this window in the bottom right, I just took like a screenshot from NetHack, which is an old like terminal like dungeon crawl kind of thing. And I layered over like a D&D dungeon screenshot just to show you what you could do. Because now there are Python libraries that allow you to actually render graphics inside your terminal. So you could use that ImageCat Python library with curses to actually have like a text-driven like game, but with like, you know, still modern images that you've drawn, and they would all render in the same terminal window. And I think that would just be awesome, and it's gorgeous. The ncurses or the curses library can be a bit complex, so people have written wrappers and higher level stuff to make building these applications easier. So there's a third-party Python library called Blessed, which actually makes designing this stuff easier. And yeah, that was it. That's how you can build super fun, cool terminal applications. So go do the things. Anyways, that was it.
Yeah, that's awesome. There's something about like ASCII type art that's so much more satisfying than, I don't know what you'd call normal art, like rasterized art, I guess.
Yeah, definitely. I've always loved that aesthetic, the cool terminal art that you get. Like Gmail has that one theme that's all like dashes for drawing borders and lines and stuff. It's cool.
Yeah, that's sick. Awesome. Perfect. Thank you so much.
Thank you.
Can you link that in the I guess the stream questions?
Yep, we'll do.
Perfect. Thank you, Nick. And then what time is it? 7:51. Okay, so we're gonna be on break till 8. If anybody wants CCR credit, the code is right in the window there. Let me find the link. Oh, Nash already did it. Perfect. Thank you, Nash. Cool. Yep. So when we return, we'll come back with our featured guest speaker, Neil Desai, talking about networked defense basics. So looking forward to that. All right. Welcome back, everyone. Next up, we have our guest speaker, Neil Desai. I hope I'm pronouncing your name correctly. Neil Desai is a principal security strategist at Elastic. And if you don't know about Elastic, they are the creators of the Elk stack. So you'll get to know them well as you learn more about information security. So some notes on him. He has over 2 decades of information security experience. In past roles, he's built security operations centers, SOCs or SOCs, and architected defensible and monitorable, that's hard to say, infrastructures for Fortune 500 US financial institutions. Neil is also one of the architects of C3X, which is coming up soon. Definitely root for Sheridan. I'm biased, but it's fine. So yeah. So if you're interested in C3X, tune into that. And he's giving us a presentation called Network Defense Basics. It's about defending a network. Starts with protecting it, And so we'll go over some network architectures, configurations that can be utilized to help defend a network and enable better monitoring. So Neil Desai, take it away.
Well, thank you very much, everyone. Especially we're getting late here on the night, and it's you guys had some great presentations earlier, so hopefully I can do them all justice by bringing it all home. So I do work for Elastic, so we can talk about Elastic stuff at the end, but right now I'm talking about things that are generic. When I look at kind of where the blue team has gotten, the frustrating thing is it doesn't seem to be nearly matching the tempo of learning for red teams, right? Because if you think about everything you learn, all the conferences, all the blog posts, a majority of them are aimed at offensive technology, whether you're a hacker, whether you're a pen tester, whether you're a red team or anything like that. And very little talks about the other side. When they do talk about the other side, it's usually around, hey, how do you harden an operating system, an application, or a very specific technology that unfortunately the attacker is going to interact with in some way and attempt to bypass, right? So if you think about like PowerShell, when it first started out, everyone's using PowerShell. Microsoft got better, started giving you PowerShell logging. Then the Defender started turning on logging. Then Microsoft gave you a constrained language mode. And then, so they keep upping the ante on that. But at the end of the day, when an attacker is on a system and they have some way to interact with the system, regardless of what you've done, there is a possibility that they're going to either bypass what you did or they're going to be able to negate what you did to achieve their objectives. Does anyone disagree with that or have a different thought on that? Be honest. Everyone's just quiet.
Oh, they're all
I
muted.
couldn't agree more.
Unless you're
I
a presenter,
couldn't
you
agree more.
can't speak. So if you want to look at the stream question.
I was gonna say, I think that what you said about the whole like red teaming and blue teaming thing is like so true. Everything is tailored towards red team. I completely agree with that.
And it's frustrating. So one of the reasons I joined Elastic is because I want to make the companies that I work with, give them a fighting chance at what to do. Right now, some of that's logging, which is all great. But one of the problems, and again, this is just all my opinion, not saying it's fact, is first you protect what you own. After you protect it, then you enable the logging to start detecting the things. But too many times people rely strictly on logging without understanding what a log means or how to put it into context. And that can lead to a bunch of problems, false positive, false negatives, missing things. There's so many things. So what we're going to talk about is first, let's force the attacker to play our game. Right. So they come into a host. The first thing they're probably going to do is after, they send their malware, they send their, Excel thing that we talked about earlier today. That thing needs to get outside of the network, right? Even though it's doing something small, it needs to go grab that secondary payload to start establishing persistence to, get their C2 connection. So what would you say if you could either stop that from happening or force them to go through a very specific path so you have full eyes on that particular channel? Would you say that's something useful for you?
Yeah, full eyes is amazing. You learn so
Yeah,
much.
I mean, to give ability, and they can't really bypass it because it's network level stuff. There's nothing they can do on the host to change this. All right, so let's talk a little bit about what we're going over here is basic protocols here. So most of the time when people talk IP, they're talking IP addressing, but we're going to go into the weeds a little bit here with IP and learn about the specific fields here, how they matter to us, how I've used them back when I was a network pen tester, and then how to kind of block and monitor for some of these things. And then go into ICMP. Usually when people say ICMP, they think of ping right away, right? The ping utility on Windows or Unix. But there's a lot more to it than that. How UDP interacts with things and how UDP and ICMP kind of work together. And then specifically DNS and HTTP, because those are great channels that are being utilized today to get data, either out of a network for exfiltration or part of a C2 for communication. So when we look at the IP protocol, right, this is the technical header here. And so the things we're focusing on, again, are the things I've highlighted in red. So we have the time to live, we have the protocol field, and then we have what we call is the flags field over here. And so when we're looking at the internet protocol and we talk about TTL, does anyone here have experience with the TTL field or understand what it does and kind of how it works?
I think third years and fourth years would have a decent amount of experience with it.
Anyone want to give it a shot at what they think it is without Googling it and cheating?
Tahano91 says, time to live.
Yep, time to live, right? And so essentially what happens is if you use a utility like traceroute, so the black screen on the right is my traceroute, and I'm doing just a traceroute to Microsoft, it sets a TTL of 1. That packet gets to the first router. Each router will decrement the TTL by 1, right? So then when it gets a TTL of 0, it means, oh, I can't continue to forward this packet anymore because it's kind of run the course. And so I send back a message, an ICMP TTL exceeded message saying, hey, that can't happen. So then the traceroute probe say, okay, now I'm going to send out a packet with a TTL of 2. The first router gets it, sees it, decrements it by 1. So now the TTL is 1, sends it to that second router who gets it, decrements the TTL by 1, and now I'm at 0 again, and it makes its way back to the original host. And traceroute continues to do that, keep updating that TTL by 1 until it gets to its destination. And so if you've never understood the mechanics of traceroute, now you do, but essentially that's how it works. So why is there a TTL? With routing, right, you have all these routers out there, you have a different path, and there is a possibility that there could be a routing issue to where routers kind of point back towards each other as saying, hey, you're the next hop. No, you're the next hop. No, you're the next hop, right? Kind of we had earlier today with some of the conversations where it's just like this endless thing. So the TTL is a way to stop that from propagating. So after you reach so many hops, essentially you've gone too far through too many hops, and the packet will get sent back to the originator saying, hey, I went too many hops. I can't go any further. Does all that make sense to everyone? Or anyone need a little bit more explanation on that? Nope. Okay, so once we get through all the slides, sorry, go for it.
I just wanted to like, are you looking at the stream questions channel? Because I just like, that's where a lot of people participate and like answer your questions and whatnot. So if you're not looking at it, I just want to make sure that you're looking at it.
I am now. All right.
Awesome. Super. So that's where you're going to get most of your engagement from.
Gotcha. Okay, cool. Thank you for educating the old guy here.
No worries. I'm sorry.
No problem. So anyway, right. So we've probably all used it at some point in our IT stuff here, doing that. But essentially that's what it is. So after we get done with understanding how these protocols work, then we're going to see how attackers can use them. And as defenders, what can we do to make changes to make their life significantly harder? So here is a Wireshark capture of me doing traceroute. And so you can see, right? So if I go back to my thing, you can see that each one of these columns here, unfortunately you can't see my mouse, but if you look at the column, for column 1, it says less than a millisecond, less than a millisecond, less than a millisecond, then 192.168.1.1. That is sending 3 packets to that 192 address. Then the second hop, right, where it changes the TTL to 2, each one is 1 millisecond. It's sending to that 69.131 address. Then it sets the TTL to 3 and sends it to the 69.128 address. When we look at this here, you see that same thing. So my first packet, we can see TTL is set to 1 for the first 3 attempts of traceroute. Then we can see the TTL is set to 2 for the next 3 attempts. Then the TTL is set to 3, 4, 5, and so on until it reaches the end. And so this is what it looks like at the low level packet here. All right, so we went over TTL. Does anyone have any questions on that before we move on to protocols? I'm checking the session. I don't see anything coming up, but just thought I'd wait and ask. Thank you for that, Yusuf. All right, so internet protocol. So IP, right, when we looked at the diagram of it, it can actually have many different protocols on top of it. Now, unfortunately, most of us just interact with things like TCP and UDP. However, ICMP is another packet that can write on top of it. So I'm going to go back real quick. Right, this protocol field here, as soon as it comes back in the middle, that determines what the next layer up is. Again, most of us deal with just TCP, UDP, and sometimes ICMP. However, if you go to this wiki page link here at the bottom, there's, I think, about 140 different protocols that can live on top of IP. And so here it begets the problem. If you're relying strictly on your firewall to do traffic dropping based on things, it's used to a world with IP and things like TCP, things like UDP, but it may not be used to seeing things like GGP, which is gateway to gateway protocol, or other ones here, packet radio measurement protocol, like all these unique things. And if it's a protocol, that means it has a specific format to be constructed and deconstructed or transfer information. Again, IP is just this thing that says, hey, I'm taking this higher layer data from one place to the next place. I really don't care what that data is, but this protocol will tell you how to decode it. So this is an area that if your firewall doesn't understand it, it may just let it through and not log it, right? And that's a bad thing when you don't have logs for things that you don't know that are going through. One other thing is IP6 encapsulation is actually a protocol that lives on top of IP version 4. So again, there's so many different protocols here, and we just need to be aware that they're there and then see how are we going to monitor for that, or how are we going to block it and then monitor when someone attempts to use it in ways that they shouldn't. Any questions real quick before we move on to routing? This one's a little bit different, a little bit more in depth, but hopefully we get through it here. Unfortunately, no, the default behavior is not always to reject. It really depends on how the code is made and do they have a default, because a lot of times these things, they're sitting in the middle of traffic and people sometimes rather fail open as opposed to closing something and only not block what has been defined strictly in there. Because the problem is if I go to close, I could block legitimate traffic if I didn't know that I was supposed to let it through. You'd think it should go to close, but you can never trust any security product or any product for that matter, right? If it is technology, there are assumptions that people made when they did the programming of it. And so if they didn't know that there's other protocols, they might not even be looking for it, right? And it might just be something that slips through the program. One example of that is back in the day, we had moved from a Cisco PIX firewall to Checkpoint firewall. Stood it up and I'm like, great, I want to scan all my network to kind of see what gets by my firewall, because I knew that routers were attempting to be used as firewalls in some cases. They had some things with access control lists, or ACLs for short, that gave them certain ability. And I knew how to bypass a router. So I'm like, let me take these same techniques to the firewall and see what I could do. Now, my testing was a little bit, I guess, more scientific because I also had a network sniffer. So I had the sniffer behind the firewall capturing traffic specifically from my home IP address. And then when I went home, I would do all my testing and then come in the next day and see what made it past the firewall. One thing that was interesting is DNS traffic was passing through the firewall without being logged. I was like, how the heck is this possible? And so essentially what I was doing is I was spoofing a DNS reply. So I was setting my source port to 53 and setting the destination port as high and just shoving that through when it actually got through the firewall. What I didn't know is in the Checkpoint firewall GUI, there were certain things you could check, and one was allow DNS traffic. And essentially what it did is it created a rule behind the scenes that allowed that traffic to come through without any logging. Had no idea. It took me doing the testing to find out there was an issue. It took me calling support to find out exactly what's going on. And it took a lot more work to get down to the bottom of this. So things you just need to think about is things don't work like you think they do. They may not work as expected. And that's where testing comes in, right? You need to just be sure. At the end of the day, like I said, I work for US Financial 100, Fortune 100s. I don't want to rely on a product to do something unless I have a higher confidence it's actually going to do it. So I did test all my products, whether it's networking gear, whether it's routers, whether it's my IDS, my IPS, if I had to rely on it, I had to know at what point is it going to fail, so I know exactly to what level I can trust it to do its job. At what level can I trust it to give me the information I need to make a decision, right? Because again, if I'm doing incident response and I have to go in front of the board of directors for the company, I got to know my stuff. If I don't know my stuff and things go south quickly, that's the end of my job and possibly my career. And I just don't want that to happen. So yeah, great question. Any other questions? All right, so next we're moving on to routing, right? Again, a lot of people, we know about IP addresses. We kind of know what they look like, and we just assume that when I send a packet, it magically gets to the other end. Unfortunately, it is not Star Trek. There is no teleportation. It uses something called routing, right? And essentially, I wish it could show my mouse on the screen, so I'll just kind of talk through it. If we start out at the bottom, right, I'm that bottom router. When I get a packet, I have to know, hey, I've got two interfaces, one on the left and one on the right. Where do I send the packet to? Well, that's what routing protocols are designed. They're designed to take this mesh, right, where routers are interconnected and determine what is the best path from point A to point B. And there's going to be variations in why it chooses a path. We're not going to go into that, but essentially it's picked a path to get there, right? So think about Google Maps. When you say, hey, here's where I'm starting and here's what I want to get, it draws a map for you saying, hey, take this road, take this street, make this left, right, whatever, and it tells you how to get there. Essentially, that is like a routing protocol. It's told you how to get from where you're at to where you want to be. Now, interesting enough, just because you went that path to get there does not mean you're going to use that same path to come back. Very much like Google Maps, right? It doesn't always give you the exact same path. Now, if I know where something is, that's great. The routing can say, hey, I know exactly where to send you, and this is the path you need to take, right? But unfortunately, on networks, there's a lot of times where it goes, hey, I have no idea what you're talking about. I have no idea where that is, but I've still got to figure out where to send you. And that's where this thing called the default gateway, right? And it's kind of like the last resort going, hey, I personally don't know where this is, but I think I know someone who might know, right? And so what happens is you configure this default gateway, and then it goes, hey, if I don't know where to send you, I just send you out. So your typical networks, the default gateway points to the internet, right? It just makes sense because internally into your network, you know where all those private subnets are, you know how to get throughout the network, you know all that stuff. However, you have no idea where, let's say, Google's DNS server of 8.8.8 is. So instead of you having to know where the entire internet resides from your network, you have a default route. It gets to this router, it's on the internet, and then it says, hey, where's the 8.8? And then from there, it can take it. But internally, it just knows, hey, the default gateway takes the data and shoves it out a central location that we've determined is the default way out of our network. Does everyone understand that? Any questions on that? All right, so we're tracking so far. And again, all this we need to understand because all this is going to come back when we start figuring out how do we use this to our advantage to start slowing attackers down, stopping attackers, or monitoring attackers. So please ask questions, and I'd rather get it out here before we continue to go on. So here's an interesting one. It's called now you know why it's called the default gateway. So Internet Protocol has a thing called the DF bit. This is the don't fragment bit. And essentially when IP gets a payload, it assumes that, hey, I can only carry so much of that data at a given time. If you send me data that's bigger than this, I have to fragment it into multiple chunks. And so what happens there is that the packets will get reassembled, but they might get reassembled out of order. But IP is just saying, hey, I'm going to set a flag saying that you're a packet that's too big to go in one chunk, and you're going to get a final packet later. And at some point, all that'll get pieced back together. Now, if I have a packet that's too big and I set this DF bit, right, and I say, hey, don't fragment it, but the router goes, whoa, I need to fragment it because there's no way I can handle it. It'll send an ICMP message back saying, hey, no bueno, can't do it. You asked me to send it, but the DF bit is set not to fragment it, but I got to fragment it. So you got to figure out what to do. And the interesting thing here, right? These things will go past firewalls. They'll go past a lot of technologies. It's scary how much people haven't learned from the past. I see a lot of these bypasses that are happening, and everyone's like, "Oh, this is new stuff." Who mentioned LOL bins earlier today? I know someone did when they were talking about it during the news.
I think Lue had them. Lue had them in his news story that earlier today, right?
I think it was in the news story.
Yeah,
so
he had LOL bins.
Yeah, so y'all are pretty comfortable with LOL bins, right? And what they are, right? Like y'all know the general concept of them, right? I'm gonna take silence as a yes. And that's fairly new if we think about it, right? Living off the land binaries, pretty much binaries that are already installed as part of the operating system. They're legitimate binaries, but they're being used in a way that was not intended to accomplish a task, right? So if you think about RegServe 32, it's supposed to do things specific with the registry. Who knew that you could go download something off the internet and have it run a piece of code? Something totally not meant what it's to be. Now, it's not an exploit, right? Because it wasn't exploited. It was just using the configurations in a way that was unintended. And we think about these LOL bins and the ones for Linux, I forget what they're called. We think it as a new technique. What would you say if that actually is something I learned back in 1998? Right? This is something I learned from a group called Rhino 9, and they told me how to use NBT stat for hacking, NL test, all of these things. So none of the things that keep coming out that everyone says, "Oh, this is new, this is cool, never seen before." It's like people should do their history lesson a little bit more, right? These things have been talked about for a long time. But anyway, that's why I don't think people always get it, because they don't think about this. They don't understand how things work here. So we have to understand, what is this bit set? So this is a great paper to go get and read. It's old, for like 1998, but at the time it was bypassing things all over the place, but they didn't release the code to how to make it happen. If any of you heard of a small company called Duo Security, got bought by Cisco for like 2.9 billion or something crazy. I don't know if you heard of them. Well, the CEO of that is a gentleman named Doug Song. Doug Song, when he was at the University of Michigan, was a uber hacker, and he took the ideas from this paper and turned it into a tool called IPFrag. So essentially, this acted like a router. You would configure this thing to do all your weird IP, TCP, weird fragmentation, send your data through it, and then it would automatically do all these weird network tricks to bypass the technology of the day. Some of that stuff might even work today. So I would check out the paper, read it. It's very interesting. But we need to understand, how much do we see on our network at any given time? Can we do anything on the firewall that filters for this, right? That's something that's a little bit harder to do, because most firewalls, again, are TCP, UDP, maybe ICMP based, but even then they might not be able to get too granular. And then, hey, what can I do at the router ACL or access control list to kind of limit this and then log when it sees something funny here? And these are things that we want to be able to understand and learn. Any questions here before we drop on to our next one? All righty. So ICMP, right? We always think about, hey, I know ICMP, that's about ping. I just do a ping something, I get an echo request, I get an echo reply. But guess what? Ping can have payloads, right? While the default payload for Windows is one thing and the default payload for Linux is another, I can specify whatever I want in the payload. Here's the deal. The payload doesn't matter. In a ping request, the payload is just arbitrary garbage that has nothing to do with me sending it and getting it back. They just have to fill it out. Now, I can fill it out with useful stuff. I can fill it out with garbage. I can use it as a way to transport data outside of the company. So if you allow ping or traceroute to leave your company unlogged, that is a way that I can use to get data out of your company and no one sees a darn thing. Not a good thing to have. So look for things where you have large ICMP packets. This is something that is definitely something that you want to know, because you should not see this, right? We have to understand what is normal, and then we can look for abnormal. So part of being a defender is knowing what you have to work with, right? you have the home field advantage. I don't know if you guys have heard that term before, but right, because it's your network, you are supposed to understand it. And by understanding it, you can create certain controls and environments that give you an upper hand. And that's what we're doing here, is by understanding what normally happens in our environment, we can look for them when they're doing things that are abnormal. Now, the funny thing is, recently someone came out with a paper that everyone thought was great about using ICMP for tunneling or something else. Like, this is old stuff. Been doing this for 20 years. This is definitely not new. It's just it hasn't been talked about in a long time because everyone's so focused on the application side of things that it's kind of got lost in history. Unfortunately, it just makes me feel very, very old. So UDP, right? Great protocol. They both sit on top of ICMP, but the problem is UDP is stateless, right? UDP is kind of fire and forget. I send something and I never get it back. Now, what's the problem if, let's say, I can't get to the host at the other end? Do I just continue to send data because I have no knowledge? No, this is where ICMP helps out. Hey, I have a typo. And since UDP is stateless, ICMP helps out, not UDP helps out. So here's what happens. I send something and there's no network for it to get to for whatever reason. I don't know where it is. ICMP will say, hey, that network is unreachable. You might want to stop sending packets. And then the application will go, got it. I'm not going to do that anymore. The same goes for, hey, I can't find that host and I can find that port. So ICMP works with UDP a lot, but you want to see what type of ICMP messages are you seeing on your network coming in, specifically from the outside or things going outbound, because that could be signs that someone is doing some type of enumeration, some type of discovery, weird things that are going on. ICMP can also, again, as we talked about before, if you're stuck in a routing loop, it'll say, hey, TTL expired, send it back, let's try that again. So UDP and ICMP work together, and we need to understand that relationship. So when we see ICMP traffic, what do we attribute that ICMP packet to? Is it another ICMP packet in the case of ping? Yes, it is. Or is it in relation to UDP or even TCP, right? And so we just need to understand the relationships of how these things work together so we see things in context. That is very right. People secure applications, that's great. But if I can smuggle data out, that's all that matters, right? I can't say that I prioritize one or the other. So for me, application security is more the custom application, right? Someone securing a custom Java app, a .NET app, a React app, something like that. Then there's the layer below that where people are trying to secure the well-known off-the-shelf apps, right? Your Exchange service that we just talked about, or Office, or web browsers, or something like that. And then you go into the operating system and then down there on network. For me, network is somewhat of a little bit easier win for a couple of reasons. One, when I do something at the network level, I affect the entire company, which is both good and bad, right? There's a reason that people might hesitate to make the change, again, because this change could have severe consequences that are negative if not done right or not fully thought out. However, when I make this change, it happens everywhere. The other great thing about network security is it doesn't really age badly, right? If you think all these other things have a very limited lifespan for how well they deal with the latest threats and all that. But at the end of the day, if you got to get out of my network, you have to use these protocols that are old as heck to get out of the network. So as long as I can control that and kind of modify things to my advantage, I think I can let that run and always use it and not have to keep up with the time. So, I personally am more in the network security kind of person, get that stuff down first, get that done as a basic, then move into the operating system side. And I move up the stack just like a packet would. That's just kind of the way I look at it there. Great question. So next, we need to understand DNS protocol here, right? So DNS, you make a query like, hey, where's www.google.com? Well, if you're inside a network, right? Let's think we're inside a corporate network. There's a whole bunch of routers, switches. I'm on Active Directory. They got DNS servers, all that good stuff. Well, internally, I don't know where it is. It's not in my cache. So my DNS server goes, well, I don't know what that is either. It's not mine. So I need to go ask someone else for help. So very similar to our whole IP routing situation, right? internally it doesn't know where it is, but it has to find someone who knows. This is a great depiction here, and there's a URL that explains it, right? Your recursive server does work for you. It goes and says, hey, root server, do you know about this? The root server goes, hold on, I don't know, but I know a person who does. It says, hey, go ask this other DNS server. Recursive server goes, hey, DNS server, do you know? Yeah, I know close, but let me give you someone else, right? And so there's a process that works through for DNS queries that go outbound. And the problem is when you're monitoring for DNS, right? Specifically, a lot of people try and do, hey, I want to look for DNS exfiltration. Depending where you're catching your queries, you may not get the right data, right? Let's say I'm between the client and the recursive server. The good thing there is I'm getting very specifically the client who made the request, so I can figure out, hey, who's infected, and go deal with it. If I'm unfortunately on the other side between the recursive server and the other servers out on the internet, I have no idea who the client is that made the request. All I know, unfortunately, is, hey, someone on the inside of my network is compromised. And yeah, I don't know what else to do because I have no other visibility. So if you decide that you want to do DNS monitoring, make sure you're on the right side of the DNS server, the proper side of it, I should say, to get the logs that matter to give you the information you need. Any other questions on that? Going once. Going twice. Cool, people got DNS. And the last one here is HTTP. Now, again, if you're in a corporate environment, people are probably going to use a proxy, an HTTP proxy, to get out to the internet because people don't go out to the internet just by themselves. Now, you can say, well, Neil, how's that different from my home network, right? I've got maybe a D-Link or a Netgear device. Well, those things are generic NAT devices, and all they're doing is they're changing the layer 3 IP addresses into something that can actually go on the internet and then sends the packet out. It's not doing much more than that. In corporate America, though, right, or corporate, well, I say America, sorry, I know I'm talking to Canadians here, but in the corporate world, they want to intercept that packet because they might want to do some type of inspection, right? They want to say, hey, what URL are you going to? Oh, you're going to a URL that's known to be malicious. I'm going to not let that request happen. Or, hey, I am going to something that is just illegal or illicit or gambling or something like that. It has a categorization list. And so that proxy can look at the request and make a determination based on a policy where you should, are you allowed to go? Are you not allowed to go? And then if I decide, hey, this request is allowed to go through, what the proxy does is it actually makes the request on your behalf to that end resource, gets the results back, and then gives it to you. So in this case, your computer actually has no knowledge of the end device. The proxy in the middle is the one that is doing all the work on your behalf. Any other questions other than calling my corporate America thing unacceptable? That's okay there, Joel. They allowed it. I'm good. I'm old. So everyone got these concepts because, again, if we don't understand this, it's going to make the rest of this part a little bit, very fuzzy. So I'd rather people say, hey, I don't got this. Let's do something here. All right. So now that we got all that out of the way here, let's go and see what we can do. Let me find it good. So we got this routing thing, right? So how do these things work together? So we've got this thing. Unfortunately, again, you can't see my mouse, but let's go to this left side where it says the local network. And let's pretend that router 1 is actually, is there. And then I've also got a proxy there that gets me to the internet. So what happens, right? When I make a request via DNS to go to google.com, it says that here's Google's IP address. I say, hey, where's that IP address? My router goes, I don't know. I'm going to send you to the default route to get you out of my network. Now, wouldn't it be cool if the only way to get out of my network was to be forced to use the proxy? What if you could not ping google.com, you could not traceroute google.com, but you could browse to google.com? Think about what that would do to the attackers, where they are forced to use a proxy to get out to the internet. Couple of things happen. They have to be aware that a proxy is there to configure for it. Now they can do that, right? They can read the registry, they can read the configuration of your browser. If you have authenticated proxies, it makes their job a little bit harder because now they have to find someone to authenticate to it, right? Again, something else you can look for. So a couple of things I want to do here. One, I want to say, hey, instead of having a default route that goes out, because I know the proxy does the work for me, what if we do what we call a IP sinkhole? I don't know if anyone has heard of this term before. It's like a black network, an IP sinkhole, dark net, anything like that. Ring a bell for anyone? Not really a null route, right? So a null route sends me to nowhere. I want to essentially capture everything. So instead of it going, hey, we're going to deal with ping here, right? I don't know where Google is. I get my DNS thing back. I know 8.8.8. I'm sending a packet. Instead of my router going here, I'm going to help you get to the internet. What it's going to do is say, hey, my default route is over here to the left. Let's say it's host L1. And what I've really done is I've created a network that sucks up every IP address that is not internal to the network. And in that network, I do a packet capture and I put a lot of logging, because at the end of the day, if you get to my black hole network, you shouldn't be there, right? It's kind of like a honeypot, but I'm forcing things to go there that don't know where they're trying to get to, if that makes any sense. So any packet internally that's trying to make it directly to an IP address that does not exist in something that's under my control will end up in my honeypot network, my black hole network. And again, because I've got logging there at various levels, because I've got hosts there to answer questions, I can capture that information and I can alert on anything, because essentially you should never get there. All applications doing normal application things should never end up in that honeypot. Does that make sense? All right, cool deal. So that's the first thing that we're going to do, is we're going to cut people off at the IP level, right? So if they have C2, they've got a hard-coded IP. I really don't care that IP only can live for 5 hours on the internet and they're just going to move around like whack-a-mole. That's fine. If you use an IP to get out of my network, you're going to end up in my sinkhole network, and I'm going to know that, hey, something made it there, and now that's very suspicious to me, so my investigation starts. Second part is, let's see. Yep, exactly. Yep, good traffic goes right out wherever it needs to go. But I wouldn't say evil traffic, right? Because there are times where people can fat figure things. But essentially, if it's not address space that is on the inside of the company, right? Anything beyond the border, it will go into my sinkhole network. So it could be valid stuff, it could be invalid stuff, but for the most part, that's something that's very sensitive that we want to just look for, because something went there that shouldn't have. Right now, there are going to be plausible false positives with that. There definitely are, but we have to just understand that and take that into consideration. However, a majority of the time, you're going to find that it's not really misconfiguration. It is people probing things they shouldn't be looking for, people trying to do scans for things they shouldn't be scanning for, or malware that's trying to get out via IP addresses. But at the end of the day, right, it's a great place to see what's going on. And after you do it, you'll kind of start to understand how many things normally hit traffic going on, what's going on, how things work. And then you'll be able to start making better and better decisions kind of as time goes on. Yeah, you need to block traffic. If you're just logging and monitoring extra closely, you're not doing yourself a lot of good there, right? That's not really a great way to go. It is a way to go, but I've bypassed a number of people that just do that, because at the end of the day, it's very easy to hide in a bunch of logs. Hiding out in the open is much nicer than, getting caught or being thrown somewhere else. So anyway, so that's one thing to do is, hey, let's go ahead and get them at the IP level. So I'm not understanding your thing there, Joel. If you want to jump on maybe and talk it through, I don't really understand what you're saying there. Yep, I can hear you.
I was just saying, basically, instead of just straight out blocking it, you're directing it into an area where you can log and monitor it before it decides you can't do anything, kind of thing. That's what the honeypot's for, right?
Yeah, so I'm getting it. It's not going to get any
You're making
It's
sure
not
that
going to leave my network.
Yeah. So it is getting blocked. It's just getting jumped around enough. That's why I meant the confusing it long enough so it's jumping around so it can hit a spot where you're monitoring and logging it so you know what's going on, basically.
Correct. It's not really confusing. I'm just redirecting it to an area that I fully own and operate. That's mine, that should never, ever get touched because it's kind of like the off limits.
Yeah.
So if you
confusing
got
was
there,
the reverting back to the person that said the map versus signposts thing. The confusing was more just playing
Gotcha.
on what other people had said earlier. So
Gotcha. Yeah, essentially, you see it, you can log it, you can monitor it, you could do packet captures. Like, you want to put a lot of logging on there, not just at the log level, but again, at the packet capture level and everything else, because the more detail you have, the more you can understand. Again, all you have is packet data to deal with, and that's not a lot to understand. Hey, what's the actual threat, or what's the actual piece of software that is attempting to make that connection, right? So we need as much information as we can. So let's say they get there, right? But let's say they're looking for HTTP or HTTPS or DNS. The other thing you put on that in that honeypot is a server that will respond to all of those requests, right? It should be able to respond to any HTTP request, any SMTP. You can configure various services, or you can write something yourself in Python or Perl that's just generic, that'll take a response and give back a okay message, right? Give back a positive response, allowing that client piece of software to send actual payload, to send something else. Because again, so we're trying to elicit that, whatever malware is, pen tester, red team, whoever it is, to send more data so we can understand more what we're dealing with. So not only are we sucking it into our environment, we're also putting services there to essentially listen and make it think that, hey, yep, it's a trap. We're putting this up to trap what they're doing and get some more insight into what's going on. So now that we've done this at the IP layer, I love that. I knew I was going to look for that, but someone else beat me to it. So now that we've done that, let's look at the second layer. We've got DNS, right? Again, DNS, I don't know where it is. It goes out. But think about this. When you go to yahoo.com, the only thing that needs to know where Yahoo is the proxy server. I personally don't need to know because I cannot get there directly. I have to go to the proxy server. The proxy server goes out on my behalf. So the same thing we did with IP, we do with DNS. And essentially we say, hey, Mr. Mrs. DNS server, anytime you get a request for something you don't know, we want you to reroute that to a DNS server in the black hole, right? And that DNS server in the black hole would then tell the client that, oh yeah, you're looking for, myc2server.com. I know where it is, and it reverts it back to an IP address that's in the honeypot, right? So they're working together to, again, suck that traffic in and bring them into the honeypot black hole network. Is everyone tracking so far? All right, so now we've done it at the IP layer. Now we're doing it at the DNS layer as well. So, we're sucking them in. Now, the last layer here is HTTP, right? Now we're forcing them to go through the proxy. Because we know how the proxy works, we know how DNS works, these small configurations can force everything to go there. Now, a lot of you probably have some type of IOC, right, that you get. And part of what we get with IOCs are domain names. The great thing is you can blacklist specific domain names. Personally, though, I think it's a waste of time. I think if you just separate it so you have internal DNS servers versus external DNS servers, and anything that is not internal to your company does not get resolved, the only thing that can resolve things outside the company is the proxy server. Because at the end of the day, that's the only thing that can get to the internet anyway because of how things are configured. Now, you are going to have some exceptions to this, and that's fine. But once you understand what needs to be in the exception list, whether it's a server that needs direct access because it can't do proxies and it sucks, whatever that case is, at least you have a quantifiable thing that's supposed to work some way, and you can make those modifications. Now, go back to TTL. This came up in an interesting conversation on Twitter with Sub T about talking about TTL. If we think about it, right? let's say that you've got a DMZ design, right? So you've got an internet router. Behind that, you've got a firewall. Behind that, on one interface, you've got a DMZ. On another interface, you have another router that gets to the network. People don't always put things in the DMZ that's available to the internet. Sometimes people will put things that are on the backbone or in office somewhere else and expose it to the internet. Not good, but they do it. So as an attacker, one thing I used to do is I would scan for port 80 to find out where all the web servers are. But that only tells me that it's a web server. It doesn't tell me anything about location. However, with the knowledge of TTL and how they get decremented, I would figure out, hey, let me send a TCP trace route. This is something you could do with Nmap to that same web server. And I could say, hey, this web server is 5 hops away from me. This other web server, 5 hops away. The third web server, 8 hops away. Whoa. Same company, two of them are, so many hops away. A third one is 8 hops away. That third web server is not only not near those other 2 web servers, it's behind the firewall somewhere else. And so this is where people start to use TTL to start mapping out the network to find out how many hops things are away from each other and start making guesstimations on how they think that network is designed. That's not a good thing, but it can happen. So this is where with a router up front, you can deny those ICMP messages. So ICMP TTL exceeded, you can deny that going outbound. And when you deny it, you can also turn on logging for it. So you can say, hey, what's going on? Yep. So the ones that are on logging, either they're not in that DMZ, they might be in another DMZ, right? And so I have to start understanding how many hops everything are. But all I know is there's different subnets, there's different devices between me and the end device. So from that, I'm trying to surmise, what do I think the network looks like? But using your router could be better in certain cases because you can get that granular stuff at the IP level, at the UDP, at the ICMP level, and say, hey, not only do I want you to block it leaving the network, I want you to let me know when you see it, because those are very good telltale signs that someone's trying to do some type of network enumeration. Right on the router, you could also set up an access list to look for those DF bits, for long packets. There's so many things you could do there that people just don't think about or take advantage of when they probably should. So that's the end of what specifically I was going to cover. I don't know if anyone has any more questions. You can ask in the chat. You can jump on and ask whatever you want. I don't know if it was basic or not because I've been doing it for long enough. It seemed basic to me, but it may not be basic to everyone, which is kind of why I did the regular expression of basic network architecture, right? I'm capturing the basic in a regex and I'm saying it may or may not exist. But yeah, so, look at doing this in any company that you're at. Talk to your network team about this. Definitely get their buy-in. This is something you just don't want to go and, force someone to do. Do testing, get a feel for it, but look to say, hey, if we do this, it is something that comes at, I wouldn't say no cost, because at least you're not buying a product to make this happen, right? You are making changes. You may need to have a couple of hosts or a VM for that black hole network. You might need a low-end router for it. But at the end of the day, those are relatively low-cost things to acquire for a company, and be able to explain, like, here are the benefits that we're going to get. Because that's one thing we don't do in security is we don't quantify what does it mean for the business of the company when I make this change? What is it in it for them? Right. And this is something that I think we all need to get better at doing, is explaining to the business, you're about to give me so much money. You probably want to know what I'm going to do with it and what that benefit is to you, right? So we have to get better at explaining things to that level for us to just be able to take it seriously and to have a better career.
I had a question.
Yeah.
So you mentioned a couple of times that a lot of the things that are used in terms of networks and protocols, they're all really mature, they're all really old, and you've seen them, and they're nothing's new. My question is, how do you feel about that? Do you think that there maybe should be like newer protocols, newer things that we're using in terms of networks and stuff like that? Or do you think that how networks work today with the way IP addresses work and all the protocols and routers and stuff like that, is that sufficient?
the thing with making change at that level, you're talking about trying to do something for the entire internet.
Right.
And that's going to be near impossible. If you look, IP6 has taken how long to roll out?
Exactly.
People
Yeah.
have it. And so it's
Right.
not something that's going to happen. But the nice thing is because it's mature stuff, it's just kind of there. It's
Mhm.
not like you need new technology to deal with it, right? You can deal with it with the technology you probably own.
Right. Okay. That is fair.
And
That is
it's
fair.
great to take advantage of because, like I said, because nothing's new, all they're doing is trying to take advantage of things people forgot about.
Right. 100%.
So for me, this is one way just to kind of stack the deck in your favor, right? If you're supposed to know the network, if it's yours, you own it, you monitor it, you work there, why not do these things that give you an advantage, right? So it doesn't matter what they're doing. It doesn't matter about the latest exploit, the latest bypass, the latest C2. The network is the network. They still have to get out. And so if I can control the out to either say, hey, you can't get out, or I can control your way out, right? It makes it much nicer. So even if they're able to get out and I force them to go to the proxy, at least I have eyes on some type of log that shows what happened.
That makes a lot of sense.
And there's a different story. Right now I've got to at least now I got to do some analysis on my proxy data to find out when is it being used for a C2. That's a totally different thing. But at least I'm standing a chance versus, hey, they can just get out of my network however they want. And I may or may not have logs. So the first part is, forcing something to happen in a way that is understandable before you do logs. And the reason I say that is, so I went to this one company when I was at professional services, and I had to install some software for the application that I was using. And I said, we have a really locked down desktop. You can't install software. We have to get the IT people to do it. I'm like, you got to be kidding me. Like, you couldn't have thought of that before having me come on site. And so, well, my nature is, even though someone tells me it's locked down, doesn't mean I trust them. So I started poking around. It took me 10 minutes to figure out the only thing they were controlling is I couldn't write to the system32 directory and program files directory. I could write directly to C drive. Right. And so the problem is, if they were under the assumption that it's locked down, when they get any event sent to their SIM or antivirus or anything else, the problem is they put it in the wrong context because they have a misunderstanding of how the system is actually locked down. So logs only help when you understand what is the entire context of it. For example, if you're in a Windows environment and you see a failed login for an administrator account, what does that mean? Well, before I can say what does that mean, I have to understand, did they rename the local administrator account? Because that's good general practice, is take the default admin account, rename it to something else, give it a really hard, strong password, set it so that you cannot log in and password never expires. Then you create a fake admin account that looks like the real admin account, and you do the same thing. So that way, if anyone tries to get to the admin account, it doesn't matter because it doesn't work anyway. But again, if I don't know that that is the procedure to lock down a workstation, how do you interpret a failed login for the administrator account? And so that's why, you kind of have to know how things work before you can say, yeah, that log makes sense to me. And that's in general for everything, right? If you're just looking at logs and saying, oh, I got logs, I'm good. It's like, not really, because there's so much more behind the story there. And I'm very passionate about logging, which is why I work at Elastic. But it's been a big part of my career is understanding logs, dealing with logs at scale and volume and analytics and all sorts of other craziness that goes with it.
Awesome.
So, any other questions around this? Questions around career stuff? Let's see. Insider.
I'm going to unmute everybody if they want to speak without push to talk and see.
So insider threat is a totally different ballgame, right? You're dealing with someone who already knows how things work on the inside and they're abusing their access. What they do and how they work is generally going to be different because they're probably going to utilize, hey, let me bring a thumb drive, a CD, external hard drive or something like that to get my data out. But the problem is they're supposed to be doing that work anyway. So finding when someone is doing it in a way they're not supposed to is a significantly harder task. Not to say it's not possible, but that's not generally what most security groups focus on. They usually have dedicated teams just for the insider threat program. because it is vastly different in what you look for and how you look for things. And sometimes insider threats can only be found when a friend of the insider threat gets mad and coughs them up and gives them up.
Yeah.
And that's how I've caught some of my biggest insider, someone else. Someone had a question?
I think it was just because her mic was unmuted and they
Gotcha.
feature up.
That's funny that someone calls it mature because they have all these teams. Having all these teams just means you have the budget to have a team. It doesn't mean that you're actually good at any of those things, right? That's something we want to make a distinction on. There are teams that are small, but are really, really good at what they do. So don't make an assumption that because they have a big staff that they're competent.
Oof, shots fired.
I've seen it a lot. I've been doing professional services for 8 years, and I've run into so many companies that swear they know what they're doing. They're really good. And I'm like, really? That's what you call hacking? That's what you call forensics? One group said, oh, yeah, we do reverse engineering. It turns out they ran binaries through a sandbox. I'm like, that's not reverse engineering. Like, oh, but we also run strings. Like, that still isn't reverse engineering, right? Until you're breaking out like IDA Pro or some type of disassembler, doing that dynamic analysis, static analysis, to me, that's reverse engineering. The flare challenges, that's reverse engineering. But people want to, have the title or sound call. It's like, yeah, but that's not really what you're doing. So especially when you're looking at, getting your career started, it's very important that you pick the right organizations to work for that are going to support you in your growth as a security professional. And so you need to kind of look for telltale signs. There was 2 jobs that I worked for where the person interviewing me was a charlatan. And when I mean a charlatan, it means that they were just a liar. They had no idea what they were doing. And I'm not sure how they got the job, but they were really good at lying to get the job. And I had to deal with them during the interview.
Did you get the job?
I did. And then I got those people fired after I got the job.
Oof.
Because having people like that is a detriment, right? I need people who can actually get the job done. Not knowing everything is fine. It's, that's the norm, but being able to be honest and say, hey, here is the limit of my knowledge is something that a lot of people are just not willing to do, right? They want to say, yeah, I know this and that and make up stories. It's like, hey, this is who I am. This is what I can do. I'm sorry if you think I should do more or could do more, but I can't. At the end of the day, here's where my knowledge starts and stops, and that I got nothing else, right?
Hello.
Hi.
So I have a question. If those people were honest, do you think they would have kept their job?
No, they really had no idea what they were doing, right? And that's the thing is I've been to so many companies where the hiring manager isn't technical, so they have to rely on their skills to try and get someone in. And if the person gets in at the right time, they make believe all sorts of crazy stories about their abilities. But the problem is that person is now in charge of hiring other people, so the situation doesn't get better. But I've had a lot of people I used to be a hiring manager for a point in time, and then for a longer period of time, I was the technical validator, right? So the manager would look to me to do kind of like a technical check of the person to make sure that they were technically sound before we moved them on to the next stage of the interview. And I had people fail really, really quick. My shortest interview was 30 seconds. Right? They just lied so hard and got caught so quick it wasn't even funny.
Like lie in terms of what? Like technical skills?
So I said,
with like...
Yeah. Oh yeah. The one person said, yeah, my favorite port scanner is Wireshark. Like, really? You got to have some mad skills to be port scanning with Wireshark. Had another person that said he monitors all the user activity somehow magically through his firewall logs. I'm like, really? So you can see what programs are running? Oh, yeah. I'm like, yeah, I don't think so, buddy. And it's just stuff like that. If it's on your resume, it is fair game for me to ask a question. So don't lie on your resume. Don't exaggerate. If it's on there, I can ask anything about it. If you tell me you're an expert in something, the problem is expert is not a definition. So while you think you're an expert in it, what happens if the interviewer is 10 times smarter than you on that same subject?
Expert is an opinion.
Exactly. So don't put, I'm an expert in this. be very quantitative on what you know and the limits of your knowledge on your resume.
Neil, I have a question.
Mm-hmm.
Yeah, I've noticed that the larger an organization is, the less security teams understand sort of like how the network is segmented, and the less context they have about day-to-day operations. I'm just wondering, in your opinion, what is a realistic level of visibility for a security team from a network perspective?
The problem is they don't have the relationship with outside. So the bigger the company, the bigger the team, the more siloed they are.
Mm-hmm.
If you were to go say, hey, do you have a recent network diagram? I have yet to see a company produce one for me. That's a problem. If you don't know how your data leaves your network, you're already behind the game. You're in deep trouble, right? So part of it is, hey, get to know all the other IT units in the company, get to know management structure, get to know people, befriend people in all the different departments, befriend people on the business side, and have them help you get the information you need. When I ran a SOC, we definitely had a up-to-date network diagram. I knew how things went out. I knew what went where. I had to. It's part of my job. So with that, right, you can work with other teams to get the information you need. You can help them do configurations, right? You can do a lot of things, but sometimes you have to realize what you want them to do may not be in the best interest in what they want to do. So sometimes you have to find a happy medium. Right? We can't just be security people say it's our way or else. You can't do it any other way. If you do, you suck. You can't do that. It's like, no, man, we got to work together. And a lot of it is soft skills.
So if I understand correctly, if you're like in a very big organization, right, where it's like not realistic for the security team to have, you know, a network diagram for every department, what's important is that you can approach like the sysadmin for that specific network segment and ask for an up-to-date diagram in like a very rapid fashion. Is that correct?
Well, the thing is that networks aren't built by departments, right? Networks are built by the engineers that architected the entire thing. They should have an understanding of how they architected the network. Now, some may have more detail, some may have less detail, but it's like, hey, how does the network broken up? Can you give me the high level address space? How many routers? Give me something that tells me how data flows through the network, right? And they're doing it at a low level. So they're not concerned with businesses as much as here's where my physical devices are at. Here's all my routers, my switches. Here's maybe the port connections. Like they know how things interconnect. That's what you need. Now, the next level down is starting to find out where do all the servers and applications live. Well, that has to still map to the network diagrams in some way, shape, or form. But not having knowledge of how something can leave your network is a really bad place to be. Because you think you're monitoring everything, I can almost guarantee you there's a few spots where traffic can get in and out of your network and you have no idea. And those are the same ones that the attacker does have an idea about and is probably using it to get inside and out.
Yeah, when you talk about incompetent, like giant incompetent teams, shouldn't they be, so if they're running external audits, wouldn't they be like found out fairly easily?
No, because they just hire more people to do the work, right? They'll hire a big firm that does pen testing, that hires the college grad. They throw them in a suit, tell them to run Nessus, and just swap out the Nessus scan with their company logo and hand it and say, here's your scan. It's like, well, that wasn't valuable. It wasn't accurate. It wasn't really any help, but that's what these larger companies do.
Interesting. I didn't know that.
Yeah. And so a lot of pen tests, like I really am very worried about who's going to do an external audit. If they are not a specialty company that does this thing, I don't trust them to do the work. So I can't say names, but there's a lot of big companies that offer a lot of services that I would never touch with a 10-foot pole when it comes to that type of activity.
You have to audit the auditors.
Auditors can actually be your best friends, internal audit. Depending external audit can be helpful. And the only reason I say that is their word is taken for truth. A lot of times it has a lot of weight. So if you can help them see something that's wrong in your environment and they call it out, that's one way to get things fixed. Truth be told, that's how I got budget one year. Is I kind of invited the auditor out for lunch and told him everything that was wrong that I wasn't able to do. They wrote me up. It looked very bad, but you know what? I got money to fix it.
That's interesting.
So, and these are part of the political games, right? You have to learn how to operate in the corporate world. Having the idea that I'm security, I'm going to go in there and I'm just going to lay down the law and I'm just going to do what I say will not get you far at all. Security here is a very small community, so you do have to watch your reputation. So if you're known in one place as being bad, that will spread. All right, question, sorry.
Yeah, just changing gears a little bit. So we recently just put together our C3X team. You are, of course, a C3X organizer. I was wondering if you had any advice to share with that team. I see some of the members actually listening right now.
Yeah. One, when I look at this, it is a competition, but it's also education. Having a team that works together is paramount. Having a bunch of people that all want to be the hero and the rock star is a sure way to lose. Having people with very specific skill sets, specific knowledge is also helpful. The job that no one wants is team captain, because that person really doesn't do as much work, but what they do is they coordinate the efforts of everyone. They're kind of like the router for the team, essentially, right? They get the business injects, they know who's up to what, they're kind of keeping track of everything. Because a problem is if you don't have that, a request comes in and all of a sudden, all 10 people in the team are trying to solve the exact same thing and no one's doing the things that, that other people kind of forgot about. So you do need someone to coordinate exactly what's happening and kind of be that go-between and make sure, hey, Neil, you've been working that a while. I think you need a little bit of help, right? Let's get someone else over to help you, understanding the skills and personalities of the team to make all that jive. Because I've seen a lot of teams fail due to lack of leadership. And leadership doesn't mean that you have to be technical. Leadership is a skill all in and to itself.
So I have a question. I guess stop me if this is too much information, but in terms of organizing our team, what do you find is usually the best way to do it? Sorry, I'm also kind of new to this too as well. So we have our first big meetup, I believe
Okay.
tomorrow. But do you normally like separate it from like applications, or do you how do you normally divide up the teamwork?
So I usually, and this is going back to when I actually did DEF CON CTF stuff and how our team captain organized us. It was based on our skill set. We had people that were specifically good at reverse engineering and pen testing. We had specific people that were good at forensics. And I was, hey, guess what? The logging and defensive guy. So everyone had their specialty. And so like when our offensive team would get shell on a remote box, they would hand that shell off to the forensics person, right, to go do the pilfering so that they could work on the next exploit. They didn't continue to do any work after they got in. And so everyone had their skill set and they knew exactly where do my skills start, where do they stop, and who do I hand off to when I'm done, right? And that was a huge reason we were able to work very well together, is because we had that kind of cohesive thing to, our team captain make sure that we had skills in all levels. So when I wanted to join, funny enough, it was the last spot they needed. And I didn't know this, but they needed a defensive networking person. Everyone that was trying to get on his team wanted to be the hero and the red teamer and, their exploit writer. And they're like, we have enough of that. We need someone that does something else. So I actually sent them my professional resume to prove that I'm not kidding. I'm really a defensive person at heart. And that's how I got on the team.
Thank you for your response.
Understanding that skill set, making sure you understand if they say, hey, Luai is a Windows person and he knows Windows. What does he knows Windows mean? Like exactly to what depth do they know Windows? Because a lot of people will say, oh yeah, I know it really great. And it turns out after they log in, they're done. Right? So you got to understand, I know where their skills start and stop. Make sure you've got a good depth of coverage. If this thing is going to go for multi-time, make sure you've got scheduling down because people get burnt out. Make sure people are getting breaks. Again, as a team captain, right? Making sure you've got a schedule that people can follow. How are you going to manage everyone remotely is another skill set. And so while these are not specific technical things, there are things that, can definitely make or break a team. So someone said, what's their mission objective and what do they do? Who's they? What they are we talking about?
I believe C3X.
C3X, got it. Yeah, it's pretty much a capture the flag type exercise where it is geared with a little bit of business injects as well to try and treat it like you're actually in a company dealing with something. Hopefully I'll be able to get some free training out to people here. It's going to be, all Elastic based, just like last year. So feel comfortable in Elastic. You're not going to be bringing your own searches like last year. You're not bringing a bunch of pre-populated stuff. It's, know how to utilize the tool that'll be given to you.
You can't bring your saved searches?
No, last year people bought really bad saved searches and almost crashed the cluster because people don't know how to write good saved searches. They use a lot of regular expressions. They don't understand what regular expressions done on a decently sized cluster with a decent amount of data. So to prevent that, I don't want anyone bringing stuff. And again, last year it was people just, instead of learning, they just brought like every Yara rule known to man and threw that in Elastic and said, hey, it'll find something. It's like, that's not how you do it, right? If you think about, if you're going into a real environment, a corporation, are you going to do that on day one? Bring all your saved searches from home and load it into the production sim and see what happens? Probably not the best thing to do. So treat it like that, right? You have to understand what's available to you. You have to understand what things look like. You have to understand what's talking and what, and just get a lay of the land before you can even start to formulate good from bad and different and all that kind of jazz. But if you come into it just laying things down like, boom, shotgun approach and seeing what sticks, yeah, it's not a good way to go.
From my understanding, C3X this year is going to be using log replays or something like this. Like as opposed to having a live red team, it's just going to be you already have the scenario and you're going to be replaying these logs into the sim. Is that correct?
I can neither confirm nor deny the ability of a true red team to be there. So all we can tell you is that the experience is going to be real for you.
Because from my discussions, I heard that C3X is going to be using similar style to OpenSOC CTF, where they're replaying the logs and packet captures and things like this.
Yeah, but the OpenSOC's NDR uses a live red team. All right, so there are pieces of live activity in there as well. But those are things, don't worry about getting hung up on, is it live, is it replay? None of that really matters because at the end of the day, you're going to be facing a situation that's real. Because at the end of the day, someone wouldn't be able to tell one way or another what's going on. That makes sense.
Sorry,
The main reason, sorry, go ahead.
Please go ahead.
Okay. Main reason I'm asking is because previous competitions, we were using like remote desktop to get into the system. Maybe we were looking for some artifact on the system itself.
Yeah, so this year it's
doing like auto runs, doing WMI persistence check, things like this.
Yep. So this year it is log access only. There's no systems for you to interact with.
Mm-hmm.
Lessons learned from last year.
When you use the free OpenVPN.
No, because people trashed their AD environment because they didn't know what they were doing.
Which school was that?
Many of them killed their entire network so bad that we couldn't recover it in like the first couple of hours. It was frustrating for us because all the months and hours sweat pouring in and people didn't understand how to really work in Active Directory. Instead of taking a safe approach, they brought in configurations that were untested from the internet, locked down the system and just blew things up left and right. And we spent all night trying to recover VMs and get things done, and we just couldn't get it back. So this year, there's no system for anyone to touch. You get logs. You'll be accessing all the logs through an ELK system, so you'll have access to data as it's coming in, streamed in live from hosts in our environment. So on the back end, right, we've got attackers, we've got defenders, we've got all that doing work on the back end, and you're kind of like a SOC, right? You're sitting there on the sideline getting this stuff streamed into you, and you've got to make sense of what you're seeing.
Sorry, I don't mean to be redundant in asking this. So if it is redundant, feel free to just like not answer it. But I'm just so in what you just said right now, and how you talked about splitting up the teams. Would there really be I don't see how splitting up teams is splitting people up into teams is kind of effective in a situation like this where everyone's just looking at maybe not the same thing but very similar things. Um how does that work? What is your advice on that?
So what happens if no one's looking at the cloud logs versus the operating logs versus the network logs?
So it's kind of like split them up into like people should be looking at like different.
Yeah, because if you know Windows, looking at a network log might not be very helpful to you.
Right.
Versus if you're the networking person, you're like, oh, I can look at the network stuff all day long and I can make sense of this and I know what to do. And I can take that knowledge and help the networking guy, the Windows person or the Linux person out. Right. So part of it is understanding, hey, here's what we're going to drop into, right? And hey, here's what I need. Windows person, tell me everything you know about Windows in these logs. Hey, Linux person, I need you to do the same. Like everyone here, you've got half an hour, come back, give me a report on what are we dealing with. Right. Once you start understanding, hey, this is what we're dealing with, then you can start to formulate ideas of how to attack things. But if you just say, hey, we're just going to go in there and start throwing down safe searches and dashboards and enable all these rules and we're going to win, probably not.
Gotcha. Thank you.
Because essentially you just started running, but you don't really have a direction of where you're running. You don't know what you're defending. You don't know what you're looking at. Does that make sense?
Yeah, that makes a lot of sense. I really appreciate that. Thank you.
Yeah, no problem. Yeah, so kind of think of it like the talk I just gave, right? Understanding what you own is a big part of it. You're day one analyst. Spend the time, but quickly. It's a contest you don't have forever. Figure out what's going on. Right, so green behind the ears. What does the team need? Documentation is a big thing that's overlooked because IT people hate documenting, but it's a necessary thing to do. Accurate documentation, drawing diagrams, whatever you can do to be a part of it, to be helpful during this time.
So sorry, if I may, I wanted to go back to, I guess, an earlier bit of the conversation. So when you were saying that we may or may not be facing real live pen testers, red teamers, basically, I wanted to know, and I was curious, will we be able to get live feedback? I guess, will the teams be able to get live feedback?
What do you mean by live feedback? So you're getting
So-
live logs as they're streaming in from the hosts.
Yeah. So I mean by sorry, I should. So by feedback, I mean.
Sorry, I can probably answer that, Neil.
Mm-hmm.
Yeah. So when you say live feedback, I assume you mean like mentors telling you,
Yeah, like if we're doing the correct things, and like after obviously the exercise is done, do we ever get a review at the end that says like, hey, you did this and this wrong, and how to improve?
Right, makes sense. Yeah. So we'll definitely go over this tomorrow in a lot of detail. But to give you like the short answer right now, yes. So one is that you will get a debrief after the game is done, telling you sort of how you did, what was the exact scenario, what you missed, and what you found. And also during the game, you'll have basically mentors. We haven't figured out exactly how the mentors will work yet. So it might be like by skill area, it might be by school. And essentially what they're going to be doing is whenever you have a question or something that's kind of unclear, you ask the mentor. The mentor will never give you an answer, but they might point you to resources that might help you answer the question, or they might teach you how to do something. Hope that answers your question.
Yeah, that's perfect. Thank you.
Yeah, no worries.
Any other questions here? I know we're going on about an hour and a half, so hopefully that's okay for y'all. They said I could go as long as I wanted, so I did.
We've gone quite a bit long.
But hopefully it was enjoyable. Hopefully you learned something from it too that you'll be able to take back to your jobs, your first jobs, whatever, and try to implement this stuff to kind of, do and start winning. But it's definitely something to just start to learn more about so you can figure out how to do it the right way.
So I actually had a question as well too. I'm not sure if maybe like you want me, since we're running out of time, maybe to like
No, go
message
for
you
it.
directly. Okay, yeah. So basically, this one's I guess a little bit outside of scope, but since I know you work with Elk and the enterprise environments, yeah, I had a question, and I was talking during the meeting. I was talking with a couple of other individuals, and we kind of see a pattern, and I actually wanted your input on it too as well. So IDS, we kind of noticed that there are some companies that do not, I guess, create a rule set, and I guess create their own customized rule set. I guess maybe I wanted your comments or thoughts on that. Like, is it set to a point now where I guess the standard and default rule set is enough security for most enterprises, or I don't know if you could comment on that.
You're talking about intrusion detection devices?
Yes, and yeah. Wait, intrusion detection system. Yeah. Sorry, yeah.
Yeah. So I used to be a huge fan of IDSs. In fact, back in the early 2000s, I used to write articles on intrusion detections. I was very involved with Snort documentation of all things, the internals of it, utilizing it. And it's just over time, it got less and less useful, in my opinion. Because think about it. The minute I go HTTPS, what happens to any network traffic? Right? You're lost. The minute I go to encrypted traffic, you're blind. Okay, that's one easy way to kill an IDS. Kind of sucks. And it's an easy one, especially when Google forces everyone to have HTTPS connections to utilize Google, and they're forcing the internet to have HTTPS. Now it's normal that every connection is HTTPS. So what's the IDS going to do? Two IDSs, they were never really great at finding stuff. They were great at generating a lot of false positives, but unless you're a real packet head and you understand packets, and not only are you capturing the offended packet, but you have enough to be able to catch the rest of the stream, be able to reassemble it, put it in context, it's not very useful to just get IDS alerts with no additional data. So I'm not a big IDS person. Now, NetFlow is a different situation, but IDSs in general, I haven't had anyone that can really say they're awesome. People love them for weird reasons, but when I push them to show me the value, they start to fall apart. And this is from a person who, at most, I had 36 different IDSs in my production environment.
Sorry, awesome. Thank you. Appreciate the response.
Yeah. And like I said, back in the day, I loved them. They did great stuff, but it's just I'm not sure that they give everything that people want now. I think if you're going to spend the money, especially as networks have gotten faster, right? Getting an IDS that could do line speed on a 10 gig network gets very, very pricey. So back in about 2008, when our DMZ went to 10 gigabit line rate for the internal DMZ, guess what the cost of a single IDS was for me? $500,000. And I had to do that times 4 because they wanted to have multiple points of access in that DMZ. And then it's really hard to justify, that much money and say, what exactly do I get out of it? So deploying IDSs also comes with its own issues. Are you using a span port? Are you using a tap? If you're using a tap, is it getting bidirectional data from the tap? Is it only getting unidirectional data? Then you have to piece it back together. How do you know you're actually getting the data from the right part of the network? How do you know that that hasn't got changed in the last couple of months? There's so many other things that go into it that people don't think about. And I've been to a number of different customers who IDSs were woefully screwed up because someone didn't know how to check everything. I think the worst was they had an MSSP that they were paying a good amount of money a month, and We got into a little bit of an argument when I was first there. They finally gave up on the argument, decided that they were going to humor me to show me I was wrong. When we dived into it, it turns out the IDS had been monitoring the wrong part of the network for over 5 years. And the reason it saw nothing is because it was looking in the wrong part of the network. But that was a professional IDS installation from a well-known MSSP. But no one thought to check, is it in the right place? Is it the right port? Is it the right network? And it's basic stuff like that. And I've encountered that over and over again. Right? Do you have checks in place to check that just because I set it up today right doesn't mean that an intern messed it up and screwed it up somewhere along the way? I've had people trip over a network cable and plug it back in, but plug it back into the wrong place. I've had people make changes to switches or routers that change the way that packets move through the network, and all of a sudden I'm blind. There's so many different things that happen where it's like, hey, you got to know how to check. You got to have these proactive things to go and make sure things are working the way you expect. So it's a lot more to IDSs than people realize. I think it really goes for kind of any technology though, right? There's so much more and people just make assumptions on it.
Neil, just one final question, actually.
Yeah.
Do you want a job here? Do you want to teach us like every day?
Unfortunately, the money just isn't there. I do like mentoring people. I love helping people out. So I do it through different areas. Last week, I was doing a session like this over at Mohawk College. I've done a lot of this because in my experience, most colleges don't teach cybersecurity properly. They teach outdated things, antiquated things, or sometimes just things that are totally wrong. And a lot of it comes from, to teach security properly, you need someone who's been in the trenches to know what's real and what's not. When you have a professor who's never done it, they may have well-intentioned, but right, they don't know how to teach it. They don't know how to do it. They can't teach from experience. They can't say, oh, I've encountered this. This is how it works in the real world. Or, hey, here are other things to think of. Having done this for 20 years, I've been beaten up a lot. I've done a lot of mistakes. I've screwed up. I've gotten beaten up for my mistake, all that kind of stuff. And all that, it's just experience that helps me say, hey, you know what? Here's something you might want to think about that. The only way you would know it is if you've been through that situation. And it doesn't mean that I've been through every situation. It just means I've been through a lot of situations.
Well, all I meant, Neil, was that your presentation was awesome, and I think everybody agrees with me. And if you do want to teach here at some point, you just have to let us know.
Well, thank you very much. If you guys want me to come back every month or couple of months, something to do, either a presentation. Presentations aren't bad, but honestly, it does take me time to create a presentation, make sure everything's thought out. But when you have just like jam sessions like this, where it's like, hey, we just want to talk to a professional and get some questions answered about the real world, those are fairly easy for me to do. So, if you guys want to say, hey, we want to do this maybe, once a quarter or something like that, or once a month or once every couple of months, something like that, help us out. Or if you give me a topic to speak on where I don't have to prepare anything, yeah, it's much easier.
Yeah, that's a cool idea.
Wow.
Definitely keep that
That's
in mind.
incredible.
Because I want to help people, right? It's not just about the technical. There's a whole soft skill side. There's, hey, how do I get started? How do I get a career? How do I move up in my career? What are my options for a career? Like all these different things that no one really talks about. It's just, hey, go get the degree, go get the certification, and you're good to go. It's like, I wish it worked like that.
No, it's incredible.
Yeah, well, we'll definitely keep that in mind. I guess we'll end it here.
So can I ask a really dumb favor from everyone here?
Go for it.
So in this chat of string questions, if you could just put your thoughts down real quick on what you thought, because what I would like to do is take a screenshot of some of this and send it to my boss, because they're not aware of the things I do outside of work and how does it impact people. It's kind of weird. So I work at Elastic and they do security to some degree, but they're not really aware of the things that I do outside of the company to just help the community out, right? So I'm still trying to explain what C3X is to my boss. But yeah, anything you want. If you don't like it, that's fine too. I'm not looking for everyone to say I was awesome, even though I know I was. But yeah, put down whatever you thought so I can take a screenshot, send it to my boss, and that way they can say, oh, this is what you do in your nights. I'm like, yeah.
Absolutely. We will definitely do that.
Thank you, Kurt. I'll definitely highlight that one into my boss. But yeah, I like helping out. Where are y'all located out of?
All of us
GTA.
are in the GTA in the Greater Toronto area. Most of us are probably within a 45-minute drive maximum from each other. I'm saying most because now that it's virtual, we have I think Sheridan. I think our program has students that are living all over the world right now and just participating virtually in their classes, as well as the ISSessions meetings.
All right. So when travel gets back to normal, Canada is one of the areas that I do cover for Elastic. And so I used to go to Toronto quite often, Montreal, and I made one trip out to Ottawa. So once, things get back to normal, we could try and hook up and say, hey, let's come and, maybe I come there for a couple of days and we put like a jam session together.
Wow.
Name
the
day. Amazing.
Name the day.
Or whatever else, right? And so yeah, once travel opens up, let's chat again because Elastic has marketing money that we can put towards this, right? Buy pizza for everyone, buy drinks, whatever, get that kind of sponsorship from us to do that. And so yeah, I love doing that kind of thing. I just need things to get to a place where we could do that.
Yeah, these are fantastic ideas.
Amazing.
But yeah,
I don't even know what to say. I can't like.
Get a hold of me. Sorry, what?
I was gonna say I don't even know what to say. That's like such a awesome offer. Thanks so much.
I like helping people, and I like helping people who actually want to learn. My frustration is when I try and help people and they don't do any work. They show up unprepared. And they expect me to do everything, right? If y'all put in the work and show some effort, then I'm more than willing to help because I'm like, hey, you really want to learn. You really want to do this thing, right? I've gone to schools where literally I do everything and they do nothing. And it's very draining. And so I stopped doing that. So I limit, who I interact with. Yeah, so
no, yeah, amazing. Yeah, I completely agree. We have a lot of motivated people who, if you came out, would definitely, be extraordinarily interested and attentive.
So and even the virtual stuff, right? If you say, hey, we want to do a learning session where you teach us something and you guys pick a topic, the biggest thing is as long as I don't have to do any preparation, that's what eats up the time for me is doing prep.
Mm-hmm. So maybe we could prep something and then your input on it.
Yeah, you say, hey, hey, can you show us about logging? Or hey, how do we parse logs? Or hey, how do we do this thing? And it's just like a live jam session where we're helping each other out. Not a problem. And I've got corporate Zoom so I can have a more interactive experience through Zoom because I can set it up like in a webinar format where a lot of people can watch and then a couple of key people can do more interaction with me. Depending how many people, it could just be a regular meeting where everyone can interact.
Yeah, that's awesome. Yeah, that'd be a great idea.
So I think it sucked on this one is you couldn't see my mouse moving around.
Yeah, Discord's not. It's convenient and it's
yeah.
That's basically why we use it, right?
It does what it needs to do, right?
Mm-hmm.
I have a question.
Yeah.
So I like to ask this question to a lot of people who I think are successful in their careers. In 3 words, what do you you contribute your success to what? Is it reading, practice, in very simple terms?
So there's the answer that people want to hear, and then there's the truth.
Or the truth?
God. My relationship with God. I contribute everything I have to Him. That's a simple answer. Now,
well, as a religious guy myself, I can hear you, but also there has to be a worldly aspect, no?
It's a lot of work. I put a lot of time into reading and learning. I don't do official courses for the most part. There's so much out there for free to learn that you can do. A lot of it is being able to be focused. You're not going to be able to know everything and do everything. You can chase all the different things and get very frustrated in chasing it. I say find something you want to be good at and stick with that thing, whatever that thing is. Right? Because even the offensive side, defensive, it doesn't matter. It's very easy to start getting into trying to figure out everything and be good. That takes time. But a lot of it is just, hey, do you want to continue to learn? This is an area where you're not going to stop learning. And that's frustrating for people because they think, oh, well, I got my degree or I got this certification, I'm good to go. It's like, yeah, but technology keeps changing. You got to continue to learn the new way, the new thing, or apply old principles to new attacks, all this kind of stuff.
I understand. Thank you.
Yeah.
Okay, we'll call that the final question, I guess. Thank you so much, Neil. Thank you everybody for coming out tonight and sticking with us till 9:40.
I don't know if that's good or bad, but yeah,
that's not good. It's good
That's
because you have people's
fantastic.
attention. Like,
Yeah, that's
you know what I mean?
really good. Really.
I'm
Absolutely.
putting my personal stuff in there in the thing. I put my Twitter link in there. I'm going to start putting more in there soon. I just haven't done it in a long time. I'm more of a reader on Twitter than a writer, but I'm going to start putting more stuff in there soon. So those are the cats that are ours. So we adopted 2. We did foster for cats, right? And 2 of them failed. But at most, last year we had 21 cats in the house while we were getting them all ready to be adopted. So lots of cats is just because you saw 4 photos, you don't know the half of it. So, yeah. But anyway. So yeah, you follow me on Twitter. You're probably not going to find anything interesting for a little bit. I'm actually trying to take this topic and turn it into a blog because someone else kind of was asking about this. I'm like, oh yeah, back in the day I used to do this. I totally forgot about this, and maybe I should make it other people aware of what they do, right, or how to do things. So we'll see what that turns into.
For sure.